Okay, we're going to see how to calculate derivatives via definition. A derivative is the slope of the tangent line of a function at a given point. Basically, you have any sort of function, like this drawing in here that you can see graphically. That drawing has a lot, infinite tangent lines around it at every single point, and every tangent line has a specific slope. That slope, or letter that is represented with letter m, is what we are going to call the derivative. Now, we're not going to see how to do it graphically. We're going to see how to calculate derivatives analytically via the definition of a slope. Remember that a slope is just the change in y divided by the change in x. So in this case, since we're talking about a tangent line, we're going to approach the change in x to 0. So derivative is basically the limit as change in x approaches 0 of a specific value, or the image of x plus change in x minus the image of x divided by delta x. What's the usual process we're going to see in this video? Well, we're going to learn how to use the formula by substituting the formula that is given. We're going to either factor or we're going to rationalize, and based on that, we're going to then cancel terms to find the limit that we're going to try to find. Once we find the limit, that will be basically the derivative. It's a long process because we're using the definition instead of using rules or tricks that may do things easier for us. But it is important to know how to use the definition in this case. So let's go right to the exercises, okay? We're going to use that formula we saw in this exercise in here. We're going to try to calculate the derivative of this function. So since I'm looking for the derivative, I'm going to use the formula for derivative. What is the formula for derivative? Well, f prime of x equals, like I said before, the limit as delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. So I'm going to substitute that. That will be equal to f prime x will be equal to the limit as delta x approaches 0 of, what is this? This is the original function that was given, but instead of x, I am going to substitute x plus delta x in there. So instead of 4x, I'm going to have 4 parentheses x plus delta x. This is going to substitute the x. That's what I'm going to do. So I'm going to write in here 4, instead of x, it will be x plus delta x minus 12. So don't forget the minus 12. Okay? This thing is the image of x plus delta x. Then according to formula, I'm going to copy now the minus. Okay, there's a minus in here. Minus of the formula. And then I'm going to copy fx. What is fx? Well, fx is this thing. The whole thing. The original function. Which in this case is 4, inside parentheses, 4x minus 12. Don't forget to put parentheses whenever you substitute the original function. All of that is going to be divided by delta x. So we already substituted. That was the first step. Now we're going to try to factor or rationalize. In order to do that, let's first do the operations and simplify like terms. So let's do that first. Limit as delta x approaches 0 of. In this case, I have a multiplication, so I'm going to multiply 4 times x and 4 times delta x. So that will give me 4x plus 4 delta x. The minus 12, I just copy it. This minus is going to affect or have an effect on 4x and minus 12. So I'm going to multiply. Minus times 4x will be minus 4x. And minus times minus will be plus 12. All of that divided by delta x. Now notice the 4x in here. Minus 4x in here will give you 0. So this is going to get cancelled with this. Now minus 12 plus 12 will also give you 0. So this is going to be cancelled with this one as well. That will leave us only with 4 delta x. We need to copy that next. So f prime of x equals limit as delta x approaches 0 of the only thing that was left in here, which is 4 delta x divided by delta x. In this case, I did not have to factor, neither rationalize. What I had to do is just simplify like terms. Okay, so we could add another or and say or simplify. either factor, rationalize, or simplify. In this case, we just needed to simplify. Notice that we have delta x up and down. We have it on the numerator, we have it on the denominator. So we're going to cancel it because it's repeating up and down. So that will be the next step. We cancel terms, right? So if we cancel those things, that will leave us with f prime of x equals limit as delta x approaches 0 of number 4. Whenever you have the limit of a number, the answer is that number. You just copy the number and that's it. The limit will have no effect on a number. So this doesn't get affected by limit. Limit basically does nothing here. So we're just going to put 4. That will be the derivative of the original function of 4x minus 12. The derivative will be 4. And that's it. So that will be case 1, when you just need to simplify terms. Now let's do case number 2. Let's try to do this one. What happens if you have a quadratic expression? Well, we're going to do the same thing. Now notice that the function in here is not called f, it's called g. So the formula that I am going to use is still the same definition of derivative, but instead of fx, I'm going to write gx. Okay, so g prime of x, or derivative of gx, equals the same idea, only that instead of f, I am going to write g. The rest is exactly the same. So limit as delta x approaches 0 of g of x plus delta x minus gx divided by delta x. It's exactly the same formula, only that I am not using letter f, I am using letter g. Now I'm going to substitute. So this thing is going to substitute the x inside parentheses. So I'm going to put g prime x equals limit as delta x approaches 0 of 3, copying from the original function, but instead of x, I'm going to use x plus delta x. So x plus delta x inside parentheses. Notice that this thing is squared, so I'm going to square plus 7 because there is a plus 7. So I copied the whole thing, okay? So I have the whole thing in here, but instead of x, I have x plus delta x. Next, the formula tells me I need to put a sign of minus, so I'm going to put a sign of minus, and then I need to copy gx. What is gx? The original function that was given in here. Gx is 3x squared plus 7 in this case. So I'm going to copy it inside parentheses. Don't forget to put parentheses. Okay? All of that divided by delta x. Don't forget that there's a delta x down at the denominator. So now what are we going to do? Well, we have to do this thing in here first, right? So let's do it somewhere else. Okay, right next to this thing we could work. So let's try to do it somewhere on here. X plus delta x squared. What would that give me? Well, the parentheses, I copy it twice. And then I multiply this with this, this with this, then this with this, and this with this. 4 multiplications. So x times x will give me x squared. X times delta x will give me x delta x. Delta x times x will give me x delta x. I'm going to put the x first, and then I'm going to put the delta x second. Then delta x times delta x will give me delta x squared. These two are like terms, so I'm going to add them. It will give me x squared plus 2x delta x plus delta x squared. That's the answer I'm going to get for this thing. So I'm going to copy the answer for that. G prime x equals limit as delta x approaches 0 of 3. Instead of this, I'm going to put the answer I got, which is x squared plus 2x delta x plus delta x squared plus 7. Okay, then I'm going to do this. Remember, the minus is going to affect both of them. So minus 3x squared, and minus times plus, minus 7. All of that divided by delta x. Well, we continue. There's a multiplication that is to be made, So g prime x equals limit as delta x approaches 0 of, I can multiply this, 3 times x squared will give me 3x squared. 3 times 2x delta x will give me positive 6x delta x. And then 3 times delta x squared will give me 3 delta x squared. This plus 7 and this minus 7 are going to cancel each other. You could do that here, or you could just copy them. In this case, I'm going to copy them, but if you decide to eliminate them before, it's also correct. So I'll put plus 7 in here, minus 3x squared, minus 7. I'm just going to copy them. All of that is going to be divided by delta x. Now, notice that this 3x squared with this minus 3x squared are going to cancel each other. So they cancel each other. Then, this plus 7 and this minus 7 are going to cancel each other. So, I'm going to mark that they got canceled. Next step will be then g prime x equals limit as delta x approaches 0 of 6x delta x plus 3 delta x squared. Those are the only two that were left in the numerator, and the denominator will be delta x. So, what am I going to do here? I already simplified, but there's no single delta x that I could cancel. I need to factor because I have two terms on the numerator. So how am I going to factor in here? Well, you just need to see what is repeating. The delta x is repeating, so you take the delta x. Now, I know that the 3 is also repeating, but I am not interested on that. I'm interested on only taking out the delta x. So that's the only thing that I'm going to factor. Intentionally, I'm only factoring delta x. So I will get limit of delta x approaches, as delta x approaches 0, of, I'm going to factor delta x, parenthesis. If I eliminate delta x from here, it will leave me with 6x. And if I eliminate delta x from here, there were 2 of them, so there will be another one left. Plus the 3 I just copied, and from the 2 delta x's that I had, only one of them will be left. All of that divided by delta x. Now, I have delta x in here, and I have delta x in here. I have them as factors, so I can cancel them because they repeat up and down. That will leave me with g prime x equals limit as delta x approaches 0 of, I'm going to copy this inside parentheses. Why? Because the limit is affecting both of them. If I don't put parentheses, it's going to look like if it only affects 6x, and that's not the case. It affects both of them. So I need to use parentheses to explain that. Once I have this, I'm going to substitute the delta x with 0. That's when you apply the limit. Now, since this delta x is going to become 0, this 3 is going to get eliminated. So this thing is going to become 0. This doesn't mean you cancel because it's an arrow and then you have a 0 in there. This means that it becomes 0 and it gets eliminated. So the only thing that will survive will be the 6x. That means g prime of x will be equal to 6x. I already applied limit by eliminating this. And that's it. That will be the answer for the derivative of 3x squared plus 7. The answer is 6x. In this case, we had to factor. So the last case that we're missing will be a case where we need to rationalize. So let's see what do we need to do when we rationalize. Okay, in this case, the function has a given name of h, which means the formula that I'm going to use is going to have the letter h, not the letter f, neither the letter g. It's going to have letter h. So derivative will be h prime of x, or derivative of h, equals the limit as delta x approaches 0 of, well, that function, right? But instead of x is x plus delta x minus hx divided by delta x. So we're going to substitute. That'll be the first step. Limit as delta x approaches 0 of, remember this thing is the original exercise, or the original function, but instead of x, you put x plus delta x. So in this case, it will be 14 square root of x plus delta x. Then you have a minus in here, so minus hx is the original function, so you only copied it, 14 square root of x, divided, all of that is going to be divided by delta x. Now, in this case, it is impossible to multiply stuffs in here. It is impossible to subtract them because they're not like terms. It is impossible to factor, at least to factor something important. Yes, I could factor the 14, but that's going to do nothing. So the only way to proceed in this case, when you have this subtraction of different roots, is to rationalize. So what am I going to do? Well, I'm going to multiply, so I'm going to put a dot of multiplication, and I'm going to multiply with the conjugate of the numerator. In other words, I'm going to copy the numerator, but I'm going to change the sign in the middle, which means I'm going to put in here 14 square root of x plus delta x plus, instead of minus, 14 square root of x divided by exactly the same thing, 14 square root of x plus delta x plus 14 square root of x. So I'm going to multiply. How do you multiply this thing? Well, you're going to do it somewhere else. You're going to work separately. So I'm going to copy both numerators in parentheses. So let's do it here. It will be 14 square root of x plus delta x minus 14 square root of x. That is the first numerator. I'm going to multiply it with the second numerator. The second numerator is the same thing, but changing the sign in the middle to plus. Okay, to the different sign than the original. So we're going to do the same process for multiplication, this, and this, then this, and then this. So we're going to multiply the first ones. 14 times 14 will give me what? 14 times 14 will be 196, right? So 196 will be the answer for 14 times 14. 196. And then when you multiply, notice that it is the identical or the same exact root. When you multiply the same root, what happens is that you release the inside terms of that root. You release the argument. So I'm just going to copy this inside parentheses. It got released. There is no longer a square root here. Next, I'm going to multiply this with this. So 14 times 14 again. Well, I know that is 196. Both roots are different, so in this case, I'm just going to multiply the insides. X times x, x squared. Delta x times x will be x delta x. Next, I'm going to multiply this with this. So minus 14 times 14 will be minus 196. Square root of x times square root of x plus delta x will give me exactly the same thing I got before. Square root of x squared plus x delta x. And then the last multiplication will be this one. Minus 14 times 14 will be minus 196. Square root of x times square root of x will release the x. So the x is now released. Since it's only one thing, I don't need to put any parentheses. I'll just put it right next to the number. Now notice that these two are like terms. And not only they are like terms, but they're exactly the same thing. Only that one is plus and the other one is minus. That means they cancel each other. That will always happen. That leaves us with 196 times x, which will give me 196x. And 196 times delta x, which will give me 196 delta x. I copy this one, minus 196x. Notice that these two will cancel each other. That will leave me only with 196 delta x. So this is the one that we're going to copy. The answer for that original multiplication of numerators will be h prime of x equals limit as delta x approaches 0 of 196 delta x divided by. Now, how do we multiply this? Well, we don't. We just need to put them in parentheses, and that's it. So the delta x, I'll copy it. And the other denominator, I'm not going to multiply with it. I'm just going to put it inside parentheses as a pending multiplication. Why am I doing this? Because I'm not interested in multiplying them. I'm interested in canceling the delta x. And in order to do so, I should not multiply this. Now that I have this thing in here, notice that the delta x repeats up and down. Up and down you have delta x. So that means you can cancel it, which will leave us with the following answer. H prime of x, or derivative of h, will be the limit as delta x approaches 0 of 196 divided by 14 square root of x plus delta x plus 14 square root of x. Now this can be substituted. Now you apply the limit. That means this thing will become 0. So you will get the following. H prime of x equals, now that I apply the limit, this thing disappears because I applied the limit. It will be 196 divided by 14 square root. Since this one became 0, it no longer exists and you only have x, so square root of x. But this one doesn't get affected, so you also copy it, plus 14 square root of x. Then you have h prime of x equals 196 divided by 14 square root of x, and 14 square root of x, they are like terms, so you can add them. That will give you 28 square root of x. Notice that you can divide this. It will not give you an exact answer necessarily. In this case, yes. Sometimes you might get a fraction. So if you get a fraction, make sure the denominator stays down, the numerator will stay up. The square root of x will always remain there. In this case, in this case 196 divided by 28 will give us an answer of 7. So I will put in here 7. And this one, notice that this one is under the line, right? It's down. You need to copy it where it is. It is still down. Now I cannot divide anything else. That means this will be the answer for the exercise. So the derivative of 14 square root of x would be, in this case, 7 over square root of x. In this case, we did the process of rationalizing. You will do that every time you deal with stuffs like this one. So either you rationalize, you factor, or you just simplify. Those are the three main processes you will have to use whenever you solve or whenever you calculate a derivative via definition.